Hi folks, in this video, I'm going to show you how to perform a one sample t-test in Excel, verify it in JASP, and then how to understand the conclusions. So let's go ahead and get started. This is by far one of the more famous studies that have been conducted in the field of weight gain. And the premise of the study was that they took a group of 16 participants and they measured their weight at baseline, and then they instructed them to eat 1,000 calories extra per day for 8 weeks. At the end of the 8 weeks, they then measured their weight again and then determined how much weight each person gained during that time span. They then took the data, which was the typical weight gain for the sample, and they compared it to the known population parameter of 16 pounds. So the population known value was 16 pounds is expected to be gained if you consume 1,000 calories extra per day for 8 weeks. And so they were comparing the difference of the sample of 16 participants to the known population parameter of 16 pounds in that time period. And so the data that was collected for this study looks as such. You can see there's 16 participants here. They measured the weight before and they measured the weight after, and then they determined the difference score, which is how much weight was gained or lost during that time period. But in order to effectively move this data to the next step, we need to go ahead and calculate a t-statistic. So I'm going to back out of my PowerPoint for a second. I'm going to open up an Excel sheet, and effectively what I'm going to do is I'm going to take the data for this study, I'm going to copy it, and I'm going to just move it right over to Excel. In a real data study, you would be entering and collecting all these data in real time. To demonstrate how to do this in the class, I think this is completely fine. So what I like to do when I calculate my data is I like to take my formulas and paste them directly into the spreadsheet. And so you can see that I have a couple of things that I need here. I need to be able to determine the X bar, or the mean of the sample. I need to know the mu, or the known population parameter. I need to know the standard deviation of the sample, and I'm going to need to know the square root of the sample size. And so, in order to do that, I'm going to use and leverage some of the knowledge, skills, and abilities that we gain from the Central Tendencies and Dispersion series in order to calculate these values. So, remember, the dependent variable in this case is not the weight before or after, but it's the difference in weight pre to post. And so that's the column that I want the average of. In order to generate that, I'm going to set my cell equal to and use my average command that we learned in a previous video, open parentheses, and select the data that I want the average for. I'm going to make sure that I close the parentheses and hit the enter key, and I can see that the average is 10.408. I have a known population parameter of 16 that was given to me, and in order to calculate the standard deviation of the sample, I would encourage you to actually follow the processes to determine deviance squared, sum of squares total, variance, and then standard deviation. But for purposes of this video and to move it along, I'm going to go ahead and use the standard deviation function. And so I can click standard deviation, select the data points that I want the standard deviation for, close parentheses and hit enter. And then lastly, I can set the square root function equals SQRT, open parentheses, and I have 16 participants in my data set. So I'm going to close that, and there I have those pieces. Okay, once I have that, to calculate the t-statistic, I'd like to address the numerator first and then the denominator, and then take the ratio of those two. So to figure out the numerator, remember, I need X bar, which is the X mean, or the sample, so that's that 10.408, and I want to subtract it from the known population parameter of 16. And you can see that I get a delta of negative 5.59125. For the denominator, I'm going to want to open parentheses and select the standard deviation for the sample, and then I'm going to want to divide it by my square root of the sample size. I'm going to close that, and I have the denominator of 0.9601. So to calculate what's known as the t-observed value, I just need to take the numerator then and divide it by the denominator, okay? And when I do that, I get a t-observed of negative 5.823, negative 5.823, okay? So this is called our t-observed. I then need to know my t-critical value, and so in order to do that, I'm going to go ahead and open my t-table. And let's assume that we're using a two-tailed test, so we're going to look at this row, and we're using a 95% confidence interval, which would be p less than 0.05. So I want this column here, And my degrees of freedom in this case is going to be n minus 1. And since I have 16 participants minus 1 degree of freedom, I'm going to look at the 15 row line and see where it intersects. And you can see that the t observed is 2.131 here. And so if I go back here and I type in 2.131, I can very clearly see that the t critical value of 2.131 is surpassed by the t observed value of negative 5.823, which means that this is a statistically significant finding. How would I actually be able to verify these numbers, though, in JASP? Well, remember, as we've shown in the central tendencies and dispersion video, we first have to take just the data, not the calculations, just the data, and we have to put that into a new Excel spreadsheet, export it or save it as a .csv file, and then in JASP, upload the .csv file. So if you need a refresher on that, make sure to go check out those videos. So in order to open this up, I'm going to first open JASP, and then I'm going to go to Show Main Menu, Open Data Library, and T-Test. If I scroll to the bottom, you'll see that there's this weight gain formula here. So go ahead and click that. And in order to run the t-test, the first thing I want to do is I want to verify my descriptive statistics. And so remember, the variable that we calculated was the difference score. So let's move that over to the variables box, and you'll see that we get a very nice output. If we compare the JASP to the Excel document themselves, we can see that the mean of 10.409 is verified with the mean that we calculated as 10.4087. Similarly, the standard deviation of 3.841 is also verified. So we're on the right track. To run the t-test, you're going to go to t-tests, one sample t-test, move the difference to the variables box, and make sure that the test value here says 16, since that is the known population parameter. When you go ahead and do that, you're going to get an output of negative 5.823, which matches the t observed value that we have here, negative 5.823. The degrees of freedom are 15, which we observed when we looked at the t critical value in the t table, and the p-value is declaring statistical significance because it is smaller than 0.05. And so the assumption here is that the sample of 16 people who consume 1,000 calories extra per day, on average, are going to gain about 5.823 pounds less than the known population parameter of 16 pounds in that same time period. So this is how you would perform a one sample t-test in Excel and then verify it in JASP. And then ultimately how to interpret that data back to the research question of interest. So I hope this video was helpful, and we'll see you all in the next one.